name's Alex, and we're going to go through the endothermic and exothermic reactions lesson for VSVS today. All right, first, divide the students into pairs, and then write these vocabulary words on the board. Endothermic, exothermic, ammonium nitrate, and calcium chloride. Have the students refer to the handout for these graphs. This one shows an exothermic reaction where the reactants have a greater level of energy than the products, so energy is released. This reaction is endothermic, where the reactants have a lower energy level than the product, so energy is absorbed. All right, you're going to demonstrate an endothermic reaction with this cold pack. You're going to press it, and it pops, and it gets cold because the reaction of the ammonium nitrate in the cold pack dissolving in water is endothermic. So after you've popped it and you've mixed it around, you can pass it around the class. Next, the students are going to do an experiment. Pass out the test tube rack, thermometer, plastic stirrer, ammonium nitrate, and water. They'll fill one of the test tubes up to the mark with water. And then take the temperature. The students should look at the thermometer and record the lowest temperature on their observation sheet. Then remove the thermometer and add 2 scoops of ammonium nitrate. Then stir it with the plastic stirrer. Then put the thermometer back in and have the students record the lowest temperature it reaches on their observation sheets. The lowest temperature should be about 8 degrees. Next, show the students the molecular model for ammonium nitrate. Show them that when the bond is broken in water, the energy in the molecules is higher, and so it absorbs energy from the environment. All right, go back to the test tubes, and for this experiment, you'll need citric acid and sodium bicarbonate. Pour the citric acid into the test tube up to the line. All right. Then take the temperature of the citric acid with the thermometer. Have the students record the temperature of the citric acid on their observation sheets, and then add 1 spoonful of sodium bicarbonate. Once the bubbling stops, add another spoonful. Then have the students take the temperature of the citric acid. It should be about a reduction of 4 degrees, and have them record that on their observation sheet. Now we're going to talk about exothermic reactions. All right, next pass out the hand warmers to the students. Have them open them, shake them up, and set them aside. While they're waiting for the hot packs to heat up, they're going to do another experiment with the test tubes. They're going to need the water and the calcium chloride with the scoop, thermometer, and stir stick. In the last test tube, they're going to fill up to the line with water. And then they're going to record the temperature. They're going to take out the thermometer and add 1 scoop of calcium chloride. And stir. And then they're going to record the highest temperature the water reaches, which should be about an increase of 15 to 20 degrees. If there's a sink in the classroom, you can dump out the test tubes in the sink. If there isn't, put the lid on tightly and take the liquids back to the VSVS lab. Now we're going to show this reaction with molecular models. Remove the chloride ions, which requires energy, and replace them with water molecules, which releases energy. Now back to the hand warmers. Have the students feel the hand warmers and feel that they're warm, and then have them look at the ingredients of the hand warmers. Tell them that the missing ingredient in this reaction is oxygen. The oxygen reacts with the iron in the hand warmer to create rust. This is an exothermic reaction. Now, cut open one of the hand warmers and pour the contents into a jar. And have the students compare this jar to the jar of the contents of a hand warmer after 24 hours. They should notice that this jar is much darker in color, and this one is much redder and clumpier because it has more rust in it.